Welcome back. Problem 12-41. This problem is taken from chapter number 12, that is deflection of beam and shaft, and the book name is Mechanics of Material by R.C. Hibbeler. So statement is determine the maximum deflection in region AB of overhang beam. E is 29 into 10 raised to power 3 ksi and I is 204 inch power 4. So you can see this is overhang beam that is acted upon by load of 6 kips at a distance of 6 feet from point A, and there is just uniformly distributed load from B to C, and this load is 2 kips per feet, and at point C we have a 3 kips load. So due to this loading, this beam will deflect, or this beam will bend like this. So you have to find the maximum deflection in region AB. So let's start with the solution. So first step is that if you remove this force, if you remove this roller support, so you will be having a reaction force. Let this force is known as RB, and if you remove this pin support at point A, so you will be having a reaction force in that will be downwards, so that will be RA. So you can take it as per your own choice, but when you calculate it from the result value, you will then know that whether I have choose the corrected direction or not. So we'll find RA and RB by using equation of equilibrium. So first equation of equilibrium is that sum of all moments about point A is equal to 0, and taking the counterclockwise moment as positive. So this is point A and this RA is passing through it, so it is not producing movement. So first movement that is produced by this force, which is 6 into perpendicular distance, is 6, and this is producing clockwise movement, so it will be negative. So I will write minus 6 times 6. The second moment that is produced due to this force RB, and this RB into perpendicular distance is 12, and this is producing counterclockwise, so it will be positive. So I will write plus RB into 12. Now third moment that is produced by this uniformly distributed load when it is converted into point load. So how you will convert it? So this is the magnitude of the load, distributed load, into its length will be converted into point load, that will be 12 kips, and that will act at a distance at a half of this 6 feet, so it will be 3 feet. This will be 3 feet. So this force will produce movement, and this force and perpendicular distance is now this 12 plus 3 is 15, and this is producing clockwise, so it will be negative. So I will write minus 12 into 15. The last movement that is produced by this 3 kips force into perpendicular distance is now 18, and this is producing clockwise, so it will be also negative. So I will write minus 3 into 18 is equal to 0. So minus 36 plus 12 RB minus 180 minus 54 is equal to 0. So 12 RB is equal to 270, and from here you will get this RB will be equal to 270 divided by 12, which is 22.5 kip. So this is your RB. Now we will find RA by using another equation of equilibrium, that is sum of all forces along y direction must be equal to 0, and upward force is taken as positive. So from here you can see one force which is RA, that is downward, so minus RA minus 6 skips, which is this one, plus RB, which is 22.5, minus 12 kips, minus 3 is equal to 0. So we will get RA will be equal to minus 6 minus 12 is minus 18, minus 3 is minus 21. So plus 22.5 minus 21 will be 1.5 kips. Since this value is positive, it means that our assumed direction of taking A downward is right. Now you have RA and RB. So what we will do is that we know that equation of elastic curve can be obtained by using this formula, EI into d square V over dx square is equal to moment. So we will find this moment by using discontinuity function or Matereials method. So what does Matereials method tell us? So if you look at this, this is a point load, clear? There is a point load, there is a point load, there is a distributed load from here, and we will neglect the last force, these three kips. So we'll start from left hand side and move toward right hand side, and we will neglect the last one. So for that we have a table. So let me copy it. This is the table that is available in book that is chapter number 12. So from this table you will take the moment equation as per your required loading. So first, starting from this RA, so you can see this is a point load that is acting, and X start from here. Okay, so first load is P. Now you can see this is the case number 2. So here point load is acting, but this point is acting, this load is acting at a distance of A from this X. Clear? So moment function is this one, and this load is upward, so this is positive. Here this load is downward, so we will take moment as negative. So moment will be equal to minus RA is 1.5 into X minus A. So A here is equal to 0, so X minus 0 power 1. The second load is this 6 kips load, and this is downward, so same minus 6 into X minus, now A is equal to 6, so X minus 6 power 1. The third load is RB, so it will be upward, it is upward, so it will be positive. Moment will be P into P will be replaced by RB, which is 22.5 into X minus A. So here A is now 6 plus 6, which is 12 feet. So X minus 12. And there is a uniformly distributed loads. You can see over here. Now we will choose this case. So this load is acting upward. So moment equation is this one. Here this load is downward. So we will take the it negative. So minus this function tells us W naught over 2. So W naught is 2. So 2 over 2 into X minus A is for this load is again this is 12, because this is starting from this point. So A, this distance is A. Okay. So this distance is A. So A minus X minus 12 power 2, because this is available, this is square. So this is the moment equation. If I further simplify it, so this moment will be equal to 1 minus 1.5 X minus 6 into X minus 6 power 1 plus 22.5 into X minus 12 minus X minus 12 power 2. Now this is your equation number A. So what we will do is that put value of M in equation A. So you will get EI into d square V over dx square will be equal to minus 1.5x minus 6 into x minus 6 power 1 plus 22.5 into x minus 12 into minus x minus 12 power 2. Now integrate it once, integrate it. So you will get EI into dV over dx is equal to minus 1.5x square over 2 minus 6 into x minus 6 power 2 divided by 2 plus 22.5 into x minus 12 power 2 divided by 2 and minus x minus 12 power 3 divided by 3. Plus there will be a constant of integration which is C1. So if you further simplify it, you will get EI into dV over dx will be equal to minus 0.75 x square minus 3 times x minus 6 square plus 11.25 into x minus 12 square minus 1 over 3 into x minus 12 whole square whole cube plus C1. Let this is your equation number 1. Okay. Again integrate this equation number 1. So what we will do is we will integrate it. So you will get EI into V is equal to minus 0.75 x cube divided by 3 minus 3 into x minus 6 whole cube divided by 3 plus 11.25 into x minus 12 power 3 divided by 3 minus 1 over 3 into x minus 12 power 4 divided by 3. So it will be multiplied with 3 and that will be equal to 12. Okay. Minus plus C1x and there will be another constant of integration which is equal to C2. So if you further simplify it, you will get EI into V is equal to minus 0.25 x cube minus x minus 6 power 3 plus 3.75 into x minus 12 power 3 minus 1 over 12 into x minus 12 power 4 plus C1x plus C2. This is your equation number 2. So C1 and C2 can be obtained by using boundary conditions. So boundary conditions are used to find C1 and C2. So first boundary condition is that at x is equal to 0, we have deflection is equal to 0. So let me show you over here. Here x is equal to 0. So we have deflection is equal to 0 because there is a pin support. So put in equation number 2. Put it in equation 2. So you will get this term will be 0. This term will be, this x is 0, so this will be 0, and this 0 minus 6 will be minus 6. That will be inside Macaulay bracket, so anything that is negative inside Macaulay bracket will be 0. Similarly, this will be 0 because minus 12 inside the Macaulay bracket will be 0. This will be 0. This will be 0. So it means that C2 will be equal to 0. So from here C2 is equal to 0. Now the second boundary condition is that at x is equal to 12 feet, we have deflection is equal to 0. So you can see over here x is equal to 12 feet. So we have deflection is equal to 0 because here you can see that this is a roller support. And also the deflection of this beam will be like this. Let me also draw it. It will be act like this. Not like this. It will be, again, let me correct it. This will be, it will deflect like this. Okay, so put in equation number 2. Put in 2. So we will get this term will be EI into V will be equal to 0 minus 2 0.25 x will be 12 cube minus 12 minus 6 cube plus 3.75 into 12 minus 12 cube minus 1 over 12 into 12 minus 12 power 4 plus 12 times C1 and C2 is equal to 0. So from here, when you calculate it, this term will be 0, this term will be 0. Only we will have 6 cube minus 6 cube minus 0.25 into 12 cube plus 12 C1. So C1 will, when you calculate C1 will be equal to 54, and their unit will be keeps into feet square. So if you are confused about units, so just forget about it and focus on the remaining problem. Now we are interested to find out maximum deflection in region AB. So we will find this equation of elastic curve. So put C1 and C2 in equation number 2. So what you will get is V is equal to 1 over EI into minus 0.25 x cube minus x minus 6 whole cube plus 3.75 into x minus 12 whole cube plus minus 1 over 12 minus 1 over 12 into x minus 12 power 4 plus C1 is 54, x plus C2 is equal to 0. So this is your equation of elastic curve that is used for deflection. Okay. Now if you know the value of x, we can see that here the maximum deflection occur that is in region AB. Clear? This is region AB. But we do not know exactly the location of x where it will be maximum. So we know that deflection is maximum where the slope of the curve, which is equal to dv over dx is equal to 0. So what we will get the equation of slope from equation number 1. So if you put value of if you put C1 in equation number 1, you will get the dv over dx, and that will be equal to 1 over e into I times minus 0.75 x square minus 3 into x minus 6 whole square plus 11.25 into x minus 12 square minus 1 over 3 into x minus 12 cube plus C1, which is 54. Okay. Now if you put dv over dx will be equal to 0, so you will get the value of x where v will be maximum. So what we will do is that we will put dv over dx is equal to 0 is equal to 1 over e into I into minus 0.75 x square minus 3 into, it will be like x minus 6 square plus this is Macaulay bracket plus 11.25 into x minus 12 square minus 1 over 3 into x minus 12 whole cube plus 54. And you can see that this is the region, so this is 0.6, this is the 6 feet distance. Focus on it, this is 6 feet distance. So this is the x where deflection is maximum. So here you can see that x is greater than 6 and less than 12 is the region where maximum deflection occur. So I will write region x is greater than 6 feet and less than 12 feet for V max, and dv over dx is equal to 0. So replace x is greater than, so if x is greater than 6, so we will have this value, and if x is greater than 6, for example, and less than 12, so this term will be negative, and in anything inside Macaulay bracket that is negative will be considered 0, and this will be also 0. So we will left with 0 is equal to 1 over ei into minus 0.75 x square minus 3 into x minus 6 square plus 0 plus minus 0 plus 54. Okay. So if you multiply ei on both sides, so you will get 0 is equal to minus 0.75 x square, and if you expand it, x minus 3 into x square plus 36 minus 12 into x plus 54. So again you will get this will be equal to 0 will be equal to 3.75 x square minus 36x plus 54. So this is your quadratic equation, and you can solve then by using calculator. So if you can see that, if you are not aware, so you can just go to this algebra, and here not algebra, you can just go to this is already in this mode. So you can see here, this is the quadratic equation ax square plus bx plus c. So a is 3.75, b is minus 36, and c is 54. So you have two values, one is 1.86 and other is 7.73. so write down this 1.86 and 7.73. so we have x1 will be equal to 1.8, or x is 7.73 feet. Since we are in the region x is greater than 6 feet and less than 7 feet, so x will be this one. So I will write it over here. So V max will occur at x is equal to 7.73 feet. Now we are interested to find out the maximum deflection in region AB. So what we will do is that put x is equal to 7.73 feet in equation number 2, or this in equation of elastic curve. This is the equation of elastic curve. So you will get V max, or you can also say deflection at x is equal to 7.73 is equal to 1 over ei into minus 0.25 into 7.73 cube minus 7.73 minus 6 cube plus 3.75 into 7.73 minus 12 cube minus 1 over 12 into 7.73 minus 12 power 4 plus 54 into 7.73. Okay. So this term is negative, and inside anything inside the Macaulay bracket that is negative will be 0, and this term will be also 0. So after solving this, when you solve this, you will get V max will be equal to 296.77, and divide by EI, and unit will be kips into cubic feet. Now we will copy it and we will move toward next page. Okay, so you have these values. So 296.77 and divided by EE is given as 29 into 10 raised to power 3 KSI. So 29 into 10 raised to power 3 KSI, and here we have kips into cubic feet multiply by I. I is 204 inch power 4. 204 inch power 4. Since this is cubic feet, so we will convert this feet into inch, and 1 feet is equal to 12 inch. So 12 cubic feet, so it will be 12 cube. Now you can see this is kips into feet, and this is KSI. Okay, so when you solve this, you will get maximum deflections comes out to be 0.0867 inch. One more thing is that you have kip above and you have KSI, which is equal to kip per square kilo pounds per square inch. So into inch power 4, and we have here inch cube as well because feet is converted into inch cube. So this will be equal to kip into inch power 5 divided by kip into inch 4, which will only left inch. So V max is equal to 0.0867 inch, and this is positive, so it means this deflection is upward. Let me show you it as well. So you can see this is positive, so this deflection is upward. And that was all about this problem 12-41. It was a lengthy problem, but I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching.